we shall study about skyways in communication system. In the frequency range from a few megahertz up to 30 to 40 megahertz, long distance communication can be achieved by ionosphere, reflection of radio waves back towards the earth. This mode of propagation is called skywave propagation and is used by shortwave broadcast services. The ionosphere is so called because of the presence of a large number of ions or charged particles. It extends from a height of 65 km to about 400 km above the Earth's surface. Ionization occurs due to the absorption of the ultraviolet and other high energy radiation coming from the sun by air molecules. The ionosphere is subdivided into several years, the details of which are given of earlier section. The degree of ionization varies with the height of the density of atmosphere decreases with height. At great heights, the solar radiation is intense, but there are very few molecules to be ionized. Close to the earth, even though the molecular concentration is very high, the radiation intensity is low, so that the ionization is again low. However, at some intermediate heights, there occurs a peak of ionization density. The ionization layer acts as a reflector for a certain range of frequencies, 3 to 30 megahertz. Electromagnetic waves of frequencies higher than 30 megahertz penetrate the ionosphere and escape. These phenomena are shown in figure 1. The phenomena of bending of electromagnetic waves so that they are diverted towards the earth is similar to total internal reflection in optics. Now a space wave. Another mode of radio wave propagation is by space waves. A space wave travels in a straight line from transmitting antenna to the receiving antenna. Space waves are used for line of sight communication as well as satellite communication. At frequencies above 40 MHz, communication is essentially limited to line of sight path. At these frequencies, the antennas are reflectively smaller and can be placed at heights of many wavelengths above the ground. Because of the line of sight nature of propagation, direct waves get blocked at some point by the curvature of the earth. If the signal is to be received beyond the horizon, then the receiving antenna must be high enough to intercept the line of sight waves. If the transmitting antenna is at height st, then by x can show that the distance to be horizon dt is given as dt by root over 2 r t, where r is the radius of the earth, approximately 6400 kilometers. dt is also called the radio horizon of the transmitting antenna. The maximum line of sight distance dm between the two antennas having height st and hr of the earth is given by dm by root over 2 r st plus root over 2 r hr, where hr is the height of receiving antenna. Television, broadcast, microwave links and satellite communication are some examples of communication systems that use a space wave mode of propagation. as shown in the figure 1. Now, modulation and its necessity. The purpose of a communication system is to transmit information or message signals. Message signals are called baseband signals, which essentially designate the band of frequencies representing the original as delivered by the source of information. No signal in general is a single frequency sinusoid, but it is spread over a range of frequency called the signal bandwidth. Suppose we wish to transmit an electronic signal in the radio frequency range baseband signal frequency less than 20 kHz over a long distance directly. Let us find what factors prevent us from doing so and how overcome these factors. Size of the antenna out serial. For transmitting signal we need an antenna or an aerial. This antenna should have a size comparable to the wavelength of the signal, at least lambda by 4 in dimension, so that the antenna properly serves the time variation of the signal. For an electromagnetic wave of frequency 20 kHz, the wavelength lambda is 15 km. Obviously, such a long antenna is not possible to the construct and operate, hence direct transmission of such baseband signals is not practical. We can obtain transmission with the reasonable antenna length if transmission frequency is high. For example, if nu is 1 MHz, lambda is 300 meters. Therefore, there is a need of transmitting the information contained in our original low frequency baseband signal into higher or radio frequency before transmission. Effective power radiated by antenna. A theoretical study of radiation from a linear antenna shows that the power radiated is proportional to 1 by lambda square. This implies that for the same antenna length, the power radiated increases with decreasing lambda. It means increasing new frequency. Hence, the effective power radiated by a long wavelength baseband signal would be small. For a good transmission, we need high power, and hence this also points out to the need of using high frequency transmission. Mixing of signals from different transmitters. There is a need for translating the original low frequency baseband message or information signal into high frequency wave before transmission, such that the translated signal continues to process the information content in the original signal. In doing so, we take the help of a high frequency signal known as the carrier wave and a process known as modulation, which attaches information to it. The carrier wave may be continuous, sinusoidal, or in the form of pulses as shown in the figure 1a and b. The different type of pulse modulation are pulse amplitude modulation PM, pulse duration modulation PDM, or pulse width modulation. Third is pulse position modulation PPM.